Hey guys, what is up? Sorry for the extremely long delay from the last video to now. A couple things happened. First, I made a video, and when I uploaded it to YouTube, YouTube said that there was no video, only audio, and I could watch it on my computer, and apparently, I mean, it's the same the exact same export settings that I use for these videos, so I don't know why it wasn't working, but that frustrated me. Then I had a whole bunch of exams and stuff going on at school, and I had other work pop up. So, um, long story short, bunch of excuses, right? So, to kind of long story short, I guess we'll just skip ahead. What we're going to be doing today is actually working on creating bullets. And the main classes we'll be working with are the input handler we have, the world that we have, the world renderer, and I have a picture of a bullet. Well, if I zoom in here, you can maybe see that we have a bullet here. Pretty fancy graphics, if you ask me. My computer performance is not slow. Shut up, Windows. If you ask me, pretty fancy performance there. Performance, bullet. I got performance on the mind, yo. If we hop back into the code, though, so we have the input handler, the world, and the world renderer. Now, the input handler is going to be responsible for when we touch down, which with libgdx, touchdown not only handles if you're on a mobile device and touch down with your finger or whatever, tap the screen. It also handles a mouse click. Now with this touchdown, the button parameter will be buttons.left. Okay, so we have a pointer, and this is basically saying what finger it was. Was it the first finger, the second finger, the third, all the way up to, I believe Android handles, some phones handle up to 20 touch down events, or 20 fingers at one time, which seems like a little overkill considering most people only have 10 fingers. 8 fingers and 2 thumbs if you're asking a third grader, but you know, people love to get technical. But you know, I suppose if you're playing a 2-player game and you have a large enough screen where both of you can be tapping down at the same time. But again, it's also device specific, so some devices only actually, you know, handle up to a few. And to be running multi-touch, you need Android 2.1, 2.2, 2.0, 2.1, I think. I could be wrong on that. Regardless, there are so many Android devices out there that have multi-touch that it really doesn't matter. Pretty much every device has it. So we can actually, once I remember exactly what it is, we can go into the Android manifest and specify the minimum SDK to be whatever we need it to be. But until then, we don't have to worry about that. But the touchdown, long story short, I keep getting off topic. Long story short, touchdown handles mouse clicks. You have a left click, you have a right click, and it also handles touches. So you have a 0 is the first finger to be touched, 1 is the second, 2 is the third. You get the idea, so on and so on. If we go through here and actually look, we don't need to look at anything. What we do need to change is changes to true, since we're going to be actually doing something with that, rather. Now, I did this video once before, and I did it so slow that I stopped and redid it. But when we touch down, we need to get an instance of the camera from the render. And this is the way I'm doing it right now is a way that I don't really like. It creates a circular dependency, which is a bad thing. And um, so to kind of, but like I said before, first thing is to get this running. Second thing is to optimize it and make it nice. And if anyone's watching this who has game design experience, if you see me make a mistake or see that I do something inefficiently, please don't hesitate to write a comment and tell me. I am by no means a well, I mean, I make money developing, but that's not to say that I am, don't make mistakes. I make plenty of them. I'm still a student, so I enjoy learning from people who know more than me just as much as the next person. So if you see something that I could work on, that'd be awesome. I mean, people have already pointed out a couple mistakes I made. For some silly reason, I accidentally, if we go into the desktop here, someone pointed out that I called the resolution 720p, and it's not. 720p would be if I made this 1280, but for the sake of we've already been doing it this way, I'm gonna leave it at 1080 by 720, which is no special resolution, really. All right. So to start off this whole bullet thing, we're gonna go in to create a new class under our models, and it's going to extend our movable entity, and it's going to be called surprise bullet. Not surprise bullet, but surprise, it's called bullet, kind of a thing. So if we go into this, I need to fix my settings so that it doesn't constantly do this to me. But we've got this, and you know what, let's go ahead and add vector 2 velocity. This dot velocity equals velocity. And we should also, I suppose, at override and public void update ship because it extends movable entity, so that way we have an update method for it. We can actually go ahead and do our update method. Let's make sure we call super.update and just send it that ship. But up here we're going to say position dot, let me double check I'm doing this the same way I did for the other ones. Position dot add velocity dot temp dot multiply. Yeah, that's all we're doing. Exact same thing. So we can actually just paste that. Whoops, actually I pasted it twice. We can just paste that, and that should suffice. And rotation equals velocity dot angle. Do we do anything special with the ship for that? Minus 90. Alright. Alrighty then. We can close out of that now. Okay. So we've got that down. Now we need to go into our world, and let's give it a way to store those. So let's use an array list for now of bullet and call it bullets equals new array list. And in case you're kind of newer to Java and or programming in general and haven't seen like when you use these arrows like this, basically if you go into an array list, let's look at the source code real quick. And actually I didn't want to use that type of array list. If I delete that, import, actually just make it an array and change to array, right? Okay, so basically if we go into the source code here, you're going to see that it says array, and then it has this arrow and T. And what that actually is it's a generic type. So basically, we're specifying it's an array that can take any type, but when we create it, we're actually capacity of 16. I wonder if... Okay. No, my performance is not slow. Stop telling me that. So basically, we're telling it here. You see, it's using this generic type all over the place when it's taking in its methods. So basically, what we're telling it is the object it's holding, and then that allows us to say that kind of lets the compiler know that, say, when we're doing something like bullets dot, it won't let us do it there. If we do it down here, we can say bullets dot get 0, and then if we put a dot after that, it will know that it's a bullet, and that's what we're returning out of that. So that's what it gives us, if that makes sense. I didn't really explain that too well, but basically it just is a generic it takes a generic object, but we're telling it exactly what we're giving it, and we're giving it a bullet. When we create this array for enemies, instead of making an array of followers and an array of whatever type we have, we'll actually make it an array of type enemy. Yeah, and then that way it gives us all the methods that are available for said enemies. Now, let's say we're going to public void add enemy, and this does add bullet b dot add b, and this does exactly what you think it does, and that is it adds a bullet to our array. And then we're going to say public array of bullet. Alright, so we have our getter and setter for this, which is awesome. We have all that set up. We'll probably end up putting private in front of all of these because right now all the other classes have access to it. But we'll fix that later. For now, it's not a big deal. Now, this is the frustrating part. This is what I didn't want to have to do, but because I'm winging it, we're actually going to do this, and this is where the circular logic sets in. Public world renderer return WR public void set renderer. Alright. Now, if we go into our world renderer, after this is, it pains me to write this because I know it's wrong on so many levels. Set renderer to this, and then the render, we're going to add a method called public orthographic camera get camera, and this just returns cam. And this is because we're going to need it to unproject our touch events. You'll see why as we kind of play through the game. It's Yeah, it's kind of a doozy. And it's kind of difficult to explain without showing. I'll try to show it as best I can since I'm implementing it already and not going to show you exactly what it does when we don't do it correctly. But yeah, you get the idea. Okay. So let's see. Touchdown events are going to handle it like this. Let's see. We need a... Okay, I added this. I forgot to delete it since I made the video, but you're going to create a new vector 3. And that vector 3 is called touch. And we're going to set that to screen X, screen Y, 0. And then we're actually going to say world.get render dot get camera. No, not get class. Camera dot unproject touch. Now we actually need a vector 2 vec2 touch equals new vector 2, and the reason I'm creating them up here is because I'm trying to avoid object allocation over and over again. May not be the best way to do it, but like I said, we're going to get this running, and then from there we'll touch.x, touch.y. Alright. Now we've got that. Now we can say world dot add bullet, new bullet. The speed will just go with 5, rotation 0, width 1, 1. The position is going to be, that's what we need. Ship equals world.get ship. The position is a new vector 2 dot get position dot x and ship dot get position dot y. And the velocity, this is what tripped me up the first time, is a new vector 2, which is, I'm trying to remember if I'm doing this the right way. You want it to go from the ship get position, subtract that dot temp dot subtract that from vector 2 touch dot normalize. Okay. I think that should be correct. Fingers crossed. Now let's go to our world renderer. And when we're rendering here, let's go ahead and create a bullets. When we import that, we'll make sure we select the right one. Bullets equals world dot. I'm not sure if I need to instantiate that. Can't remember if it's necessary or not off the top of my head. We'll get an error if it requires it. Let's draw the bullets so they're on top of everything. And we can actually say We'll create a new object, and it is an iterator bullet b iter. Alright. Now, I'll show you what an iterator is in a second. It's kind of a fancy thing. That knows what we want. Whoops. B iter dot has next. And we need to create a new texture, and this new texture bullet texture, and I already added the bullet texture into my asset folder. Data backslash bullet dot pen. All right. Alright, so we've got that. Whoops. Alright. B iter dot next. Right? Yeah. Whoops, hit the wrong button. Dot next. And we can just batch dot draw the crap. Let's just copy and paste this. Except we just need to change everything from ship to B. So this is going to be bullet texture. The ship is going to be B. B. Why did we do the ship text at half width? Oh, that's the origin. Okay. And this is the actual width and height. I don't know why I deleted that whole thing, but got that. Got that. Whoops. And that should be everything. Alright. Fingers crossed on this. That's what I forgot, though. Alright, so we're actually shooting a bullet. That being said, though, I forgot something silly, and that is calling update on them. And iterator bullet. So we just do that again. And then I was basically just set it up the same way. Alright, so this should actually update it. Alright, and I have the width and height set to 1, which is why it's scaling out that way. But I actually did this backwards. So this needs to be vec to touch, and then sub from ship.get position. Whoops. Man, I'm just not hitting anything correct right now. Alright, now let's try this out. Alright, that's... Well, we've got the rotation correct. Those bullets are really slow, and if you like, you can see that we actually outrun them. So let's change the speed. Actually, let's do it this way. Public static. Oops, I don't know why I capped it. Public static int speed equals, is it a float? Oh, public static float speed equals 15. And we'll just change this to bullet.speed. And then all we have to do from now on to change the speed is just change it in the bullet class so we know where to look. That's a much better speed. You can see we don't really outrun it anymore. Now let's go into the renderer and get the sizing right. Or no, we don't need to go in the renderer. We need to go here. We have it set to 1. The width needs to be, I think, actually I can just look at this. If I hover over it, dimensions are 2 by 8. So the ship is, let's see if I can find where my ship is hiding in all this stuff. The ship is 20 by 20, which is a width of 1. That's also 20 by 20. So this is 0.1, and then 8 divided by 20. So 0.1 f, and then 8 divided by 20 f, just to make sure it does it right. Alright, so we now have bullets shooting all over the place. Now, we need to get, how much time do we have? We didn't waste too much time. Let's get some collision going between these. Now let's say iterator enemy iter. We'll input enemy, array enemy, enemies equals new array. And we're going to do the same thing with the enemies, so we might as well go ahead and get it working. Enemies dot add. Boom. Right? Wait, a follower. Whoops. Super dot update, because update handles, yeah. And that takes the ship. Alright, instead of calling that, we have direct access now to Delta. So now we just need to call, we save that. Alright, so follower's fixed now, so that it is technically an enemy. Now instead of calling follower.update, we're actually going to do it like this. E_iter equals, well, let's make another space so it's readable. E_iter equals enemies dot iterator, and we're just going to make another loop. And do enemy E, and say E equals E_iter dot next, and of course E dot advance, which is gdx dot graphics dot get delta time, and the ship. And then here's how we're going to do this. If E dot get bounds dot overlaps B dot get bounds, we're going to say gdx dot app dot log, and it is angry masons dot log enemy hit. Exclamation points are key because we're yelling about the enemies being hit. Not that anyone's going to see it except for us. Then we're actually going to say E_iter dot remove and B_iter dot remove, and then I'm trying to think. The best way to do this. For now, this works. It's going to cause bugs later. Just trust me on it. It will later. And then which one goes to... Okay, that goes to that. We'll leave it like that. Eventually, to clean up and not have this array that just expands beyond belief, we're going to have it where once the bullet is a certain distance from the ship, it gets removed from the iterator too. But we'll worry about that later, and what that distance is going to end up being, like the width, how we did the width divided by 40, I divided by 2. So what it's going to be. basically once it's off the screen. And then instead of getting the follower, it's going to be array enemy get enemies, and it's going to return enemies, which is going to cause a bug in our render, but we can get rid of the follower object here. That was for our testing purposes. It's no longer needed. Okay. And we need to, whoops, not right there. Add that right there. So we can delete this. E. Alright. So now we're also testing our ship collision detection within this loop as well. We don't need the follower anymore, so let's delete. Oops. Let's delete that. Okay, I just had to import that. We're good there. Now we need an iterator for drawing this stuff. So let's create another iterator up here. Get another iterator. Enemy iter. So enemies dot. Whoops, spelled it wrong. Jeez, can't spell. Dot iterator. While iter dot has next. And we will tab that, give us some space here. We need an enemy E. And we'll also need one down here. But we'll get, and we can actually create the collision bounding box with the bullet too. E equals E iter dot next. E. And this is going to have to change because we won't necessarily know if it's a follower or what it is. But for now we only have one enemy, so it's something that gets to stay for now. And then let's just copy and paste this, and then delete that line, copy this line, shortcutting our way around all this, but no problem with that. And then let's do the same thing with the bullet iterator so that we can look at actually with the bounding boxes that it's using for our collision detection. Only let's take out the batch because we know that it would be bad to leave that in. B, and last but not least, B. Alright. Now let's see how this works. Oh. Wait. Didn't we... Should be advancing? Right? Equals E dot advance. Huh. So why is that not getting cold? I wonder if it's... There should be... Alright, let me look at this. Alright, now in our world... Oh. And it started working all of a sudden. Oh. That's why. See, we don't have any bullets, and therefore it's not calling this loop, which means it's not calling this loop. So we should probably... I'll fix that in a second. All I have to do is just shoot over there and it gets going. You can see it follows us around, so there's our ship getting hit, but more importantly, we can shoot, but if we hit it, the enemy's hit, and it's destroyed. We'll fix this in the next episode. This one got kind of long, so I'm cutting it off here. But, yeah, look forward for that next episode. We now have shooting and killing in our game, and what it makes a game more fun than shooting and killing spinning orange shapes. Alright, I will see you guys in the next episode. It hopefully won't take as long to make another one as it did to take this one. But thanks for the patience, and I will see you guys later.